Hello, everybody, and welcome back. So right now, we want to take a step back and look at the total energy balance of the system. We've already discussed heat transfer modes like conduction, convection, and radiation, but we haven't seen all of this come together, and we haven't seen the energy balance of a system. So in order to understand the energy balance of a system, we also must understand the thermodynamics perspective of it versus the heat transfer perspective of it. So let's just take a step back and look at the big picture. So the question that comes to everybody's minds is that what's the difference between thermodynamics and heat transfer? So with thermodynamics, we deal with energy states and energy requirements. Thermodynamics answers questions like how much energy is needed for a process? What is the maximum possible efficiency? What is the minimum work required? It does not describe how the energy moves or how fast it moves. On the other hand, heat transfer completes the picture because it deals with the mechanisms of energy movement. It answers questions like how fast does the heat move, at what rate, and what geometry material is needed. So this allows you to size reactors and heat exchangers. And it provides you with what you need to know so that you could use the right design equations like conduction, convection, and radiation equations in order to figure out what is the heat transfer rate, or how fast does the material absorb energy, or how fast would the temperature rise be. So the key message is thermodynamics tells you the required energy, but heat transfer tells you how to design this equipment, how you can optimize it to reach to the final thermodynamic points that you want to reach to. So let's start with the first law of thermodynamics,